Hey, everybody. I am here with my new friend, Dr. Sarah McAnulty. Say hi, Sarah.
Hey, how's it going?
Awesome. I'm really, really excited to be talking to you because first of all, we're going to talk about a really cool animal. But second of all, I'm also a really big fan. So I would really like it if you could take a second to kind of introduce yourself to people, let people know like what your journey has been like in studying your animal of choice.
Yeah, absolutely. So my name's Sarah McAnulty. I am a squid biologist, and I'm also the executive director of a nonprofit called Skype a Scientist. And so we'll talk more about Skype a Scientist later, but let's talk about squid for now. So I've been interested in squid since I was a little kid, and really always loved the ocean. But when I was a kid, I didn't really know like what scientists were and like how to become one or what a life as a scientist really even looked like. So, my parents also didn't really know. They were teachers, great parents, 10 out of 10, but didn't really know what scientists were, what they did. So they were like, well, maybe you'll work at an aquarium. Like, I don't really know. But then I went to college and started working with this lab in Woods Hole, Massachusetts at the Marine Biological Laboratory, the MBL. Worked with cuttlefish, which are the cutest animals, I think, in the history of animals. But we're talking about bobtail squid today. But man, cuttlefish, got to put a plug in for cuttlefish.
I love them so much. We did actually do an episode where my husband Christian talked about cuttlefish recently. And I will tell you this, they got tens across the board.
Yeah, I mean, they should because they really are, they're hitting all the points. They're great. So anyway, I did my PhD up in Connecticut on bobtail squid and their symbiosis with this bioluminescent bacterium, Vibrio fischeri, which we'll get into in a bit. So yeah, that's how I got to where I am now. I now live in Philadelphia, working with this nonprofit that I started during grad school, trying to bring science to as many people as humanly possible.
And that's, kind of so right now I'm Skyping a scientist. So
That's happening. Exactly.
and I gotta say it rules. So I'm here to say like, it's a pretty great experience. Just anything that allows science to be more accessible, and really bridge that gap between the people doing the research and the people doing the work in science and the people on the consuming end of it, the people that it's benefiting. So I'm really excited to have you be a part of bridging that gap between science and the public. That's just like what science communication is all about. So I think it's like one of the best tools out there right now for communicating science directly. So I'm really, really excited about that. So we'll get into details a little bit towards the end. But first of all, so Hawaiian bobtail squid, tell me about it.
Let's talk about bobtail squid. Okay,
Yes.
so bobtail squid live as a larger group, live basically all over the Indo-Pacific, and actually some of them even live over in like England, that area, the Mediterranean, that whole range. But we don't have any bobtail squid around the continental U.S. or Alaska. It would be too cold, I think, for them up there. So bobtail squid are generally speaking pretty small. They are also called dumpling squid because they legitimately are like dumpling size and dumpling shape. They're kind of round with a face in the front. So people sometimes confuse bobtail squid with cuttlefish because both of them have a face in the front with their arms and their tentacles, and then kind of like a bulbous behind where all of their organs are stored. But specifically the Hawaiian bobtail squid, they are about the size of like a key lime. So like an actual regular lime would be a little too big, like a small lime is how big these little squid are. And they are really, really important for understanding the relationship between beneficial bacteria and animals. And I'll get into why that is in a moment. But the Hawaiian bobtail squid has a beneficial partnership with this bioluminescent bacterium, Vibrio fischeri. And so the squid stores bacteria throughout its life in this little butterfly-shaped organ called, appropriately, the light organ. And so the light organ is basically like a combination of the squid's ink sac and then pouches where the bacteria live and grow every day. And so the bacteria at nighttime are constantly producing light, and the squid is able to tell how bright of a night it is outside. Like maybe it's a cloudless night on a full moon, it's pretty bright out. it knows that because it has receptors for light on its back. And then it uses the ink sac and other structures within the light organ, kind of like a shutter almost. And so it can control how much of that bacterial light is coming out and kind of shining out their like belly side, like the underside of the squid. And so they can control that light, which is so, so cool. And so they have this like neat little light based camouflage method so that if a predator was swimming below the squid, they're like often looking up to try to see who they can attack by looking for little prey item shaped silhouettes. And the squid, with its light camouflage, is invisible. It's like a little squid invisibility cloak because instead of seeing a silhouette, the predators can't see anything. And so that is how they avoid getting eaten because pretty much everything in the ocean is trying to eat a cephalopod because they don't have bones and they're really, really easy to eat. One of my former advisors once said they're like swimming protein bars. They're like just so nutritious and easy to eat. And so if you see a squid, you probably want to eat it if you're an ocean animal.
It's the popcorn of the sea.
Yeah, just like popcorn chicken. Just like, let's do this. No bones, real easy, delicious, adorable. So yeah, that is my overview of the Hawaiian bobtail squid. They eat shrimp, in case that's a question. That's what we have going on.
I'm very excited about this. So this is a good transition into our first category to rate the bobtail squid. So the first category is effectiveness, and if this is your first time listening to our particular show, we define effectiveness as physical adaptations that let an animal like do a better job of the thing it's trying to do. You mentioned it's light camouflage, which is mind-boggling. That's really, really cool.
Yeah.
That it's using this bacteria that it stores and intentionally, to like change the level of light output. That's just so cool. So for effectiveness for the bobtail squid, what would you rate them out of 10?
Okay, so for effectiveness, I am going to have to say 10 out of 10 because I'm sorry, how did this thing evolve? Like, it's so cool. I mean, okay, all cephalopods have the ability to change color using structures called chromatophore, or not, actually, you know what? It's not all cephalopods. It's like almost every cephalopod, but let's not get into the weeds there. So most cephalopods have the ability to change color using chromatophores, which is already incredibly cool. And these Hawaiian bobtail squid can also control their chromatophores and basically go from being kind of reddish brown to kind of ghostly white. So that's their like chromatophore range. But then on top of that, they've got the light organ. And like, I don't want to get too much into the physical like morphology of the light organ because it's kind of complicated, but it is complex in there. So you've got like a little ball of bacteria producing light. And then you have like a lens structure in there, which is kind of similar looking to like an eye, which is already pretty wild. And then you've got filters in there that are filtering what wavelengths of light come through. You also have reflective tissue that are kind of look like mirrors. They're like silvery looking. And then that's all like surrounded by the ink sac. And so that is bananas that it works, that it evolved. Like it is just so impressive that I think we got to give credit where credit is due to the bobtail squid, because even though they may not be the most athletic squid, they may not be svelte, they're just kind of like, round and adorable when you look at them. But what they have going on under the hood is super impressive. And so for those reasons, I'm going to have to go 10 out of 10 for the bobtail squid.
I have a lot of appreciation for an animal who, like me, is maybe not the most athletic and maybe a little round and adorable, but there's a lot going on inside.
I completely agree. I'm totally on team round and adorable.
So with the light organ containing this bacteria, how does the bacteria get there?
That's an awesome question. And the answer is complicated, but let's get into it because it's so cool. Okay.
Yes, I want to hear about it.
It first hatches. So the mom lays a clutch of like 100 to 200 eggs, or maybe like 50 to 200 if she's having kind of an off day. So when the squid first hatches, they don't have any bacteria on their body. So they need to recruit that bacteria from the surrounding seawater. And so when they are first hatched, their light organ looks quite different from the way it's going to look when it's an adult. So as an adult, it looks like a butterfly. Let's just go with that. But when it's a juvenile, It looks almost like a mini butterfly, but each wing of the butterfly has these two long noodly appendages sticking off the side. And those noodly appendages are covered in what's called cilia. So these little structures that beat kind of like oars to get water moving. And so when you're that tiny, they're like a millimeter and a half in mantle length. So like that little bulby area of their body is like a millimeter and a half, which is tiny.
They're so little.
So little. And water at that small volume is really viscous because, like, we think of water at kind of our scale. Like, when we're swimming, you can really move through it easily, but tiny, tiny, tiny little bits of water, they don't move as smoothly. So, the squid has this adaptation to keep water moving in that area because every time the squid breathes, it's letting water into its mantle cavity. And so that's, again, it's like the torso of the squid. And so within that mantle, all the organs are in there, but it's really open to the seawater because the way squid move is by taking water into the mantle and then using jet propulsion to basically squeeze the water out of their mantle through their siphon to zoom backwards. And so that's standard squid anatomy. So you need that constant flow to get colonized, we call it. We might need a better word for that in the future, but to get the bacteria into the light organ in the first place. So the light organ has three little holes on either side. You've got the appendages working overtime, the little noodly guys, to get water flowing. And so they create these like little eddies of flow that put just like one micron size. So that's like, oh man, how do you even describe a micron? The bacterial length, basically, particles over these three little pores. So they're specifically selecting for size of what goes over like where the bacteria need to be, which is very impressive. And then of all the bacteria in the seawater, maybe like only 1 in 1,000 cells is the right type of bacteria. Because of course, seawater is full of bacteria and viruses and other schmutz. And so they make this like mucousy layer on top of the three little pores that the bacteria need to swim down to get to where they're going to live for the rest of their lives. And so that mucus will kill about half the bacteria that live in the seawater. And then the Vibrio fischeri, the beneficial bacteria, need to actively swim down through the pores, down these ducts, and in the ducts that they're swimming down to get into the what we call the crypt, which is where the bacteria are going to hang out. They're getting hit with nitric oxide, they're getting hit with acid, and these little bacteria can handle it because they have adaptations that basically neutralize those nasty substances. And so when they finally get into what we call the deep crypt, which is like the little pouch where they're going to hang out, they've made it. And so at that point, they can start proliferating and they've gotten in. So it's kind of like these little bacteria need to go through like a gauntlet to get into the squid in the first place. And we've done some experiments with some mutants that show that, some bacteria can get into that crypt, but then get eliminated later because the squid doesn't like it. And we don't really know how often that process is happening out in the wild, but let's not get into to that too much. But the cool thing is that this symbiosis is so specific, and both partners have evolved these like super specific like checkpoints to make sure that the bacteria that gets into the light organ is the right stuff. And so those bacteria, once they reach the deep crypt, are proliferating wildly. They get fed by the squid. And then what's totally like bananas is that every morning at dawn, the squid will like squirt out 95% of the bacteria in the light organ. And we think that the reason that they're doing that is so, first of all, they have like a fresh batch of bacteria every night. So that helps them stay healthy. And then also we think that maybe there's kind of like a little tiny evolution project that these squid are engaging in. So maybe you caught a Vibrio fischeri that's like, it's okay it certainly can get into your light organ, and it's okay at being a partner. But if you give it the food that you know you're going to give it, you want that bacterium to be good at eating the food that you gave it. As an example, like not necessarily definitely true, but this is like totally a hypothesis. And so over the course of their life, they're selecting for bacteria that do the best in their light organ. And so maybe by the third week of life, you've got like a pretty good thing going. Yeah. And so that's how it happens.
I love the idea that inside of this very, very small squid, there is a true D&D style dungeon that like is like outfitted with trials that the bacteria have to like accomplish to finally like reach the treasure at the bottom. Like you have to like fight your way through it, like get past booby traps and all sorts of stuff. I really am enjoying a sort of a mental image of bacteria sort of fighting their way through this trapped dungeon to get to the core of the light organ.
It's like American Ninja Warrior of bacteria, basically, like an episode of that show. Just to start your symbiosis. It's so cool.
I really like that. I think that's really cool, and that's very, very complicated for a very small animal.
Totally. Oh, and also one thing that I would be remiss in not saying is that we also think that the reason that they squirt out 95% of the bacteria is to seed the environment for the baby squid that are coming up later.
Okay. All right. That makes sense. It's
like they're enriching their environment.
Yeah. So they're kind of looking out for their own future generations.
Yeah, totally.
Do they have any sort of other forms of like parental care?
So yes and no. So overall, I want to say no. Like mom squid do not take care of baby squid by interacting with each other. But female squid, we're going to get into some really cool stuff right now, so buckle up. So female squid have this other organ that also holds bacteria called the accessory nidamental gland. We call it the ANG. And basically, it's a collection of tubules, and each tubule has a different kind of bacteria inside of it. And so these squid can have like 100-ish species of bacteria in this organ, sometimes less, sometimes a little more. That's not like a hard number there. But they will, when the mom goes to lay her eggs, a squid egg, a Hawaiian bobtail squid egg anyway, has the little bubble where the squid lives and where it develops. And then that bubble is surrounded by many layers of jelly. And the mom squid takes the bacteria from the ANG and incorporates it into the jelly when she's laying her eggs. And then she sticks all the eggs together in a little clutch, and she covers the eggs and like decorates them with little particles of sand so that we think predators don't see them as easily. And so the reason she's carrying around all this bacteria and the reason she puts it in her eggs is that those bacteria are producing antibiotics, antifungals, potentially anti-algals. We're not really sure yet. That research is still ongoing, but they are protecting their babies using the antibiotics that these bacteria are producing, which is super, super cool. Because if the eggs don't have that bacteria in them, they get overtaken by fungus. And so if a fungal infection overtakes your eggs, not enough oxygen gets to the babies and then they all die. And so the seawater is full of life. Even if it doesn't have an animal in it, that does not mean that there's nothing living in seawater. There's a ton of stuff living in seawater. And so if you're going to set and forget your eggs, you better make sure that they're protected from all of the other things that live in the seawater. So yeah, that's the only maternal care that squid are really giving.
I think that's still pretty good, though. They're kind of setting their eggs up for success as far as hatching, right? Like kind of once you've hatched, you're on your own, but
yeah.
But at least they're giving them, a chance at making it to hatching, which sometimes is like, that's the best you can hope for. Sometimes, like, at least they hatched. You're like, thank goodness. I think it's crazy to me that they're cultivating so much bacteria within their body, but for so many different purposes. They're like running this like industrial, like bacterial agricultural operation inside of their bodies.
Yeah, no, it's really cool. And like, so one of the things that I was working on when I was a PhD student, and I was at the University of Connecticut in Spencer Nyholm's lab. His lab does so much cool stuff on squid. And so what we were really wondering is like, okay, you have all this bacteria living with you. And as humans, we absolutely have a ridiculous amount of bacteria living on and in us as well. This is like just kind of the state of life as an animal. And so how do you know what is the good bacteria? What is the like quote unquote bad bacteria? Asterisk here, bacterial species as individuals or strains even. Context has a lot to do with whether it is like good for you or bad for you. So we don't ever want to label a bacterial strain as being always good or always bad. so there's that. So don't leave this podcast not knowing that. But we don't really like have a complete understanding of how our bodies figure this out. And so to have that bacterial load in your body and be able to maintain a healthy relationship was really what we were curious about. And so my work was looking at how do the immune cells of a squid tell the difference between beneficial bacteria and everybody else.
So you were in Hawaii studying these squids. What was that experience like working with them in Hawaii? Like, was it really difficult to find them? Like, are they fragile to handle? Like, what's it like working with bobtail squids?
Yeah, so when I was in Hawaii, what we were doing was catching the squid. And so we'd go out at night, catch the squid, keep them at a lab called Kewalo Marine Laboratory. It's associated with UH. And then after about a week of collecting, we would ship them back to Connecticut where the squid would live for the rest of their lives. And so they're honestly not that hard to catch. So you go out at night in water that's like ankle to hip depth. You bring along with you just like a basic net. And then when you see a squid, you scoop it up, but you don't take it out of the water because that would hurt them. Any net contact with a squid of any kind is really bad for the squid. And so you don't want to touch a squid. You don't like their skin is so fragile and delicate that you don't want to touch a squid. So you put the net around them, you keep them underwater, and then you take like a gallon-sized Ziploc bag and you put them in the Ziploc bag, and you put that bag in a bucket. And at the end of the night, you bring them back to the lab and you give them dinner. And then eventually you're going to take them back to Connecticut. And so squidding is the best because you're not only seeing squid, of course, you're seeing moray eels, you're seeing stingrays, you're seeing pufferfish, and these sea cucumbers called conspicuous sea cucumbers, which their name is appropriate because they look like a highlighter in color, and they're like ridged and weird, and then their front end has this like little pom-pom looking face.
I love that.
They're very silly looking, and they feel so weird. Like they're like when you touch them, they're not like really solid like a lot of other sea cucumbers. They're very like squishy, and they're mostly full of water, and I don't know. Look them up. They're wild looking. And so yeah, squidding is the best.
It sounds like a lot of fun. I think I would really enjoy it just to see them. Like, I don't feel any particular need to handle them because I personally kind of have the heebie-jeebies. I have like a phobia of things that live in the water.
Oh my God.
So I'm really not a fan of touching things that live in the, and it's not just like scary things, like things that could hurt me. It's literally anything that lives in the water. They scare me very badly.
Okay, then squidding might be a little terrifying for you because there's a lot of sea animals all over the place.
I love and respect them from a distance.
That sounds good.
I still feel like it would, just to like get to see them where they live, I think would be a real treat. But so for our next category that we rate animals on, we've got ingenuity up, which for us is behavioral adaptations that let an animal solve the problems that it encounters on a daily basis. So these could be like clever behaviors that it uses or like strategies that it uses. So what would you give the bobtail squid for ingenuity?
Okay, so before I give you this score, I want to remind everybody that I love bobtail squid so much. They're wonderful. But I'm going to give them a 4 out of 10 because if we're giving the light organ to the first category, then we can't double count the light organ, in my opinion. I feel like that would be unfair. So bobtail squid are not, like I said, not super athletic. Like they are just little dumplings that are blooping around in the water. They're very easy to catch. They're not particularly fast. Like they've got one good jet in them. And maybe like, I don't know, if they're having a particularly athletic moment, maybe they've got 10 good jets in them. But then they're basically just like, whew, that was a lot. Whew, can't do it.
I'm done.
So I'm done. And so they're not doing a lot of the complex behaviors that a lot of other cephalopods are doing. Or at least if they are, we haven't witnessed them doing them. So, a cuttlefish and octopus, they are behaviorally very complex. They are really doing amazing things, problem solving, socially, like all over the place. And bobtail squid, not so much. They're basically just going out hunting, floating around and living a simple, adorable life. So they don't have here's the thing. Anytime you're working with a nocturnal animal, when you shine a light on it, are you really getting a great sense of what that animal would do typically with their behavior? Like, probably not. So
Yeah, they're probably like disoriented
we're like,
and
what the heck is going on, right? So this is also true of a lot of deep sea cephalopods. Like when we shine floodlights at them, is what they're doing normal? Like probably not. And so it's really hard to get a sense of the full range of behavior in an animal when you're doing something goofy to it. And so maybe a bobtail squid is actually an 8 out of 10, and we just don't know about it. But based on the information that I'm working with today, 4 out of 10.
That's true, because like when you're observing them and when you're interacting with them, they've probably really only got one goal in mind, and that is for you to no longer be doing that. So they're kind of just like focusing on getting themselves out of whatever situation they're in. So you mentioned earlier that they eat shrimp. Mm-hmm. So I should have asked this earlier when you talked about it, but do they have like other squids, like this little beak?
Yes, they do. So, okay. Let's talk about really, really quickly the difference between an octopus and a squid at its oversimplified level. Octopuses have 8 arms. Squid and cuttlefish have 8 arms and 2 tentacles. And so the tentacles are the feeding appendages. They're super ultra stretchy. And then at the end, they've got what we call clubs. And the clubs are basically their hands, and they're covered in suction cups. And in some squid species, those suction cups have little rings of teeth that help grab into the prey. And so
I don't love that.
I have a love-hate relationship with that. Like, I think it's so cool and kind of badass, but also for sure spooky.
Very troubling.
Very troubling. So yeah, and so in between all of the arms and tentacles, they do have the tiniest, cutest little beak. And so yeah, when they catch a shrimp, and they will often catch shrimp like that you don't think they could possibly have taken down, particularly when they're little. I have some pictures of it, and it's just so cute. And so they'll bite into them and give a little bit of a toxin to the shrimp so that it's not like riding a mechanical bull the whole time they're trying to eat dinner. They'll paralyze the shrimp and then just like munch on the side of it throughout the dinner time.
Wow. I didn't realize that there was like a venom that they had in play. That's really cool too.
Yeah. So pretty much all cephalopods have a little bit of venom that works with their prey. You know what? Venom, I think, is a specific thing. I don't actually know if this is like officially a venom or like a toxin or a poison. Like, I don't really know the words that you're supposed to use there, but like either way, something a paralyzing agent in their beak. And so some of that stuff is super toxic to us. Like, you don't ever want to get bitten by a blue ring octopus, for example, because that'll really ruin your day and potentially kill you. But if you can get bitten by a bobtail squid and it would have no effect on you, like you wouldn't notice that it had a toxin in it.
I guess that makes sense because like the prey they're going after is very, very small and we're very, very large. So
like what might affect a crustacean is not, may or may not affect a human. So their toxin is specifically evolved to work on the stuff that they want to eat.
Would they bite like defensively? Like if a human were handling them or harassing them in some way, would they bite at all? And if so, like would that hurt?
That would hurt a little because their beaks are very, very, very sharp, but they're also super tiny. So here's the thing. I worked with bobtail squid for 6 years. I never got bitten, and I was handling them as much as anybody. So, okay, one time I got bit by a cephalopod. It was a common cuttlefish. So I'm not trying to get a dig in on that cuttlefish. It was like a Sepia officinalis, the common European cuttlefish. Yeah. And so it had spooked itself. I was on the other side of the room. I was like nowhere near it, not even in eye shot. And I just heard this like, and then slap. And I was like, oh my God, what just happened? I went over there. The cuttlefish was on the ground. It had like jumped out of its tank. So I gently scooped it up and then it wrapped its arms around my thumb. And I thought, this is the worst day of its life. It's having a tough day. I'm sure it's scared. It probably just wants to grab on to hold on to something. But no, it was going into full attack mode and it bit my thumb and I bled for quite a while. But basically the moral of the story here is don't let your body get in between the arms of a cephalopod. It's just not the place you want to be. You kind of know where the beak is and they're not that maneuverable. So don't put your hands near a squid's beak and you're not going to get bitten by a squid.
Maybe just don't put your hands near a squid.
That's also pretty good advice. Yeah.
Maybe just leave them alone.
Yeah.
They're nocturnal, right?
Mm-hmm.
So is the shrimp that they hunt, like, do they have any trouble seeing it at night, or
no?
Does the light organ like provide them any sort of, I don't know, help seeing at night?
Not really, because the point of the light organ light is just to produce the same amount of light that would be in the ambient environment. So you don't really see them glowing per se, because they're trying to produce the amount of light that makes you not notice them, not that would be like a little glowing orb and make you notice them. So the light produced by the bacteria, I don't really think is helping them hunt at all, but they do have big old pupils that I think they're using just the light in their environment to hunt with.
Do they have the W-shaped pupils that cuttlefish do?
Great question. No, they don't. They've got more of an oval shaped pupil.
Okay, all right. I think those are so wild.
They're so cool looking. Yeah.
Cephalopod eyeballs, they stress me out with how complicated they are.
Yeah, I love looking at cuttlefish eyes. They're so weird and cool.
Yeah, when we talked about the cuttlefish a few episodes ago, I had to do a little bit of a deep dive to try to figure out why their eyes were shaped like that. That was really fun. But anyway,
Yeah.
that's cuttlefish. We're talking about bobtail squids.
Mm-hmm.
I know that you've worked with bobtail squids, you've worked with cuttlefish. Have you found that between the ones that you have, observed over periods of time, do they have like personalities?
So they don't have as much personality as a house cat or a dog or a cuttlefish or an octopus, but they don't not have personalities. They kind of range between like chill and like what I call nervous inkers. Like there are ones that when I walk into the room are like already like kind of getting all worked up and might ink at me even though I'm behind a pane of glass. And those are typically the ones who I've done blood draws with before. So like I deserve it. Like I don't blame them for that. Although our blood draws are done completely ethically. Like we anesthetize the squid. They're completely under. We take the tiniest little drop of blood, like less than an eyedropper drop size. And then they go about their day. We give them shrimp. They're good for the rest of the day. But it's still like kind of a spooky experience being taken from your home and then like getting knocked out and then waking back up and having a sore neck. Like that's weird. So I don't blame them for being upset about that. And then there are ones that like, you can do anything to. I could pick them up with my hand underwater, of course. And they're just like, this is fine. And so it's basically how neurotic they are. Some are more neurotic than others.
You mentioned that cuttlefish do have more personality. Is it like, I know we keep coming back to cuttlefish, and I'm sorry for derailing the conversation, but I want to hear a little bit about cuttlefish personalities.
Yeah, sure. So I worked with cuttlefish for 2 years back when I was an undergrad. And you'll have cuttlefish that actively like you. And now I wonder how much of this is due to the fact that, first of all, cuttlefish are awake during the day, and bobtail squid, whenever I would go in and the lights were on, were buried under the sand and not really interacting with me. So that might have something to do with it. But the cuttlefish, when you go in and you feed them every day, they get to learn who you are. And so they remember you. And so I had a couple cuttlefish, like some cuttlefish really don't want anything to do with humans, which is a valid approach to life. I don't blame them. But some of them would know like, oh, it's dinner time. Like, let's go. And so they'll come out and like, they literally bop their little heads out of the water. So like so a cuttlefish has, its 8 arms and then its eyeballs like right behind that. And then its siphon, like the structure that they use for jet propulsion, is right under their face. And so they could take like basically shoot little jets of water out of their siphon and then stick their little eyeballs out of the water and then under the water and then out of the water and then under the water. And it's so cute. I could just die. And so they're basically begging for food. And so they're just more interactive. And they're getting excited because they're like, yeah, I'm about to get some fish. This is going to be great. And so they're just more emotive. I think when you make eye contact with a cuttlefish, it seems like there's more going on behind the scenes than with a bobtail squid. A bobtail squid's kind of just like, whatever. And a cuttlefish, some of them, not all of them, are more engaging and interactive and just curious in general. Yeah, watching cuttlefish is really I could do it all day long.
Yeah, I think that has something to do with like the hypnotic motion of their fins.
Yeah, and like if you look at cuttlefish skin, they're constantly like shimmering because their chromatophores are like not really sitting still the whole time. So the longer you look at a cuttlefish, the more there is to look at, basically.
Oh, that reminds me that I think it was a picture that you posted recently. It was like a close up of these bobtail squids where
Mm.
they have these like iridescent colors on them, right?
Oh my God, yes. Let's get into aesthetics because that'll
Yes.
be the perfect time to talk about iridophores, which is what they're called.
Oh, perfect, perfect. Yes. Okay, this is self-explanatory. What do you give the bobtail squid for aesthetics?
10 out of 10.
How could
They're
you not?
little
They're so
swimming
cute.
rainbows. I mean, they're adorable with their big baleful eyes, and they're glow in the dark, and they're rainbow colored. So yeah, 10 out of 10.
So the in the picture that you posted, it's like kind of a super close up, and you
Mhm.
can see that they have it almost looks like flecks. It looks like almost like they're covered in rainbow sprinkles. So
That is accurate. Yeah.
what is that all about?
Yeah, so let's talk about cephalopod skin for a minute. So we're just going to talk about bobtail squid skin here for a minute and not go into all the things that cephalopods can do because we'd be talking forever. But basically, the ground layer of the skin that's relevant for this conversation is covered in these structures called iridophores. And so iridophores are little like cellular stack looking things, and they can change shape, and that affects what color we see because iridophores aren't colored themselves. They reflect color back. They're like a bike reflector kind of. And so based on like the hormones that are flowing in the squid, that'll change the shape kind of the iridophore itself, and then that'll affect what color we see. And so I don't really know how much bobtail squid are really playing with their color like that. And it's very important for other cephalopod species, but since they're in the dark, I don't really know, to be honest, why bobtail squid have so many densely packed iridophores and why they're so shiny. It's possible that it's for communication among themselves. I honestly can say I have no idea. But I'm glad they do because that means every time I shine a light at them, they look like little rainbows. And so on top of that layer, they have the chromatophore layer. And so the chromatophores are relatively large in this species, and they're reddish brown. And so if you look ultra close at a bobtail squid, you'll notice that they have different colors of chromatophores. They have the reddish brown one, they have more of like a yellow looking one. And so they open up those chromatophores to make themselves look more reddish brown and darker. But the iridophores are underneath, and that's what gives them that like sparkly appearance.
It's very fabulous. Like it looks like
Yes.
they're getting ready to give a performance of some sort. And yeah, with them being mostly in the dark, like is it possible that that is like just an evolutionary like leftover, like it's just something they don't need anymore but it wasn't hurting them so like they never got rid of it? Like is this something that you see in other squids that are related to it, that maybe it was just like why bother getting rid of it?
Yeah, I mean, that's an awesome question, and it's definitely possible. I don't know the answer to that question, but it's that's kind of what I've thought, that maybe they have. I mean, it seems wild that they could be so densely packed with iridophores and have it just be leftovers. So I hesitate to say it's just like the little stub of our tail, like the thing left over in evolution, because they have so many. So that it's possible though. Like it's possible that that's why they're there, and it's also possible that they're using it for something that we just haven't figured out yet.
Oh, that leaves so much like room for questions. Like that's a perfect mystery cliffhanger to be like, stay tuned.
Yeah, bobtail squid, we just don't know. You know, there's like so much more to learn.
It leaves the door open for so much exploration. Like there's so many opportunities there for learning new things.
Totally.
Well, I feel like that has been a very comprehensive look at the bobtail squid. I feel like I appreciate them very deeply now, whereas I knew very little about them before. So I'm very excited about that. So the next thing I want to talk to you about is Skype a Scientist.
Yeah, let's talk about Skype a Scientist. So Skype a Scientist is a nonprofit organization that matches up scientists with classrooms, scout troops, and right now during the pandemic, we are also matching with families who are stuck at on the couch at home. And so the main purpose of our program is making science as accessible to as many people as humanly possible. And so we want to give people access to science and scientists, and we also want to help scientists break out of their bubble and communicate with people. And so if you're a scientist, you can sign up at skypeascientist.com. And if you are a family or any group whatsoever, all that we ask is that a parent or an adult is involved if you have kids, because we don't want just a kid by themselves talking with a scientist. We think it's better to have a group, so at least two of you, and have one of them be an adult. You can sign up totally for free. This program is completely donor supported. And so we can have as many, if you can't afford to support us, that's okay. You should still sign up. And if you can support us, we, again, are completely user donor supported, and you can support us at patreon.com/Skype-a-scientist. And so what we do is once we match you up with a scientist, what you have is a Q&A session with that scientist. You basically have a conversation, because we think there are enough examples already online of scientists just talking at people, and we want this communication to be a two-way street. And so we want you to ask the questions that you're really interested in, and we want you to have the opportunity to get to know a scientist and learn that they're not the way we're depicted in TV and movies. Like, we're not all socially awkward white guys with questionable hair. We're no matter who you are, there's someone like you in science. And so let's say you're a family at home and you want to sign up. If you have a kid at home who's super into sharks, what you can do is go on our website, and there's a scientist search tool posted on our website, and you can type in the word shark into our scientist search tool, and all of the scientists who still have availability will be generated in a list. And so you can specifically request scientists from that list, so you can have somebody who studies sharks talk to your family. Now, maybe you don't really care. You just want to talk to a scientist of any kind. We've got 30 categories of scientists to choose from. And when you fill out the Google form to sign up, you can tell us what you're interested in learning about. And so we even have the option, if you are, or half of your group or more are from a given underrepresented group in STEM, tell us. And then we'll match you, or at least try to match you, with a scientist who's from the same underrepresented group as you. We think that that's really, really important for kids in particular, for making them feel welcome in science.
Yeah, it's really important for kids to be able to see somebody who looks like them, or who they can relate to, who reminds them of themselves, doing something that they could then imagine themselves doing. I love making that really personal connection, and it's more than just a webinar or like a live stream or something where you tune in and you watch a scientist just talk about what they're interested in. It's a back and forth, if you have a specific question, they can respond to that. And it just really gives the scientist a chance to make sure that the person that they're talking to really understands what they're saying. And I think that can break down a lot of misconceptions and do some myth busting too,
Totally. Absolutely. Yeah.
What kind of feedback have y'all gotten?
I mean, so we serve about 10,000 groups a year. So we have gotten a lot of feedback, and it is overwhelmingly really positive. So I heard yesterday from a scientist who was giving her thesis defense, or was giving a talk of some kind. I'm honestly not sure if it was a defense. And in there, she mentioned her outreach work with our program with Skype a Scientist. And she said that she started crying during her presentation because she read out loud a letter from the classroom after they had their session. And she was saying that the classroom that she got matched with was not a super wealthy classroom. They didn't really get to go on field trips. They weren't really connecting with scientists at all before our program. And seeing someone like them was just such a powerful experience. And before, the teacher said that the kids were doing okay in science class, but weren't really thriving. And then afterward, she had multiple students coming up to her after class and being like, so how would I actually pursue a career in science? Which is not something that she was experiencing before. And so the connections that we're making are super powerful. And it may seem like, it's just a one-off kind of thing. If you only talk to a class one time, how powerful is that? But I think people underestimate how powerful one experience can be if it's personal. And so, I just watched one video that I had rented out of the library to get interested in cuttlefish. And that wasn't even talking to a real person. It was just watching a video. And then once I saw a cuttlefish on the TV from this like National Geographic Kids video, it's not overemphasizing it to say that it changed my life. Like I saw that and I was like, oh my God, like I need to know everything there is to know about this animal. It like totally dazzled me. And that was just a video. So like if you're having these conversations that are personal, it's really, really powerful. And so, or at least it can be. And so we don't want to sell that short at all.
I think people underestimate like the power of a personal connection, like a conversation that you can have with somebody. So this is a really dumb story, and my mom is going to crack up if she listens to this and hears that I mentioned this. But so when I was a kid, I must have been in 5th or 6th grade. I was in this science class where they gave us this assignment. It was like a special like project that we were supposed to do, where we were supposed to pick any like famous person and write them a letter, basically like, hey, I like what you do. And, you know, just like reach out to a famous person, and it could be anybody. And so I couldn't really think of anybody. Actually, I wanted to write to Steve Irwin, but he had already passed away at this point.
Yeah.
And so I found online. So I was, of course, this was when I must have been in 6th grade. And so I was right in that like super edgy phase of my life where I was really into like wolves and stuff.
Yeah.
So I found this researcher in Italy who specialized in wolves. He was like a wolf like ecologist. And I wrote him a letter like, hey, I really like wolves and I like the work that you do. And this dude sent me a letter back.
That's amazing.
He did. He sent me a letter back and I was so floored. And my mom was like cracking up because she's like, you dork, what are you doing? Like, but I was really, really excited. And I held on to that letter for a really, really, really long time. And, you know, and now I've kind of pursued this like interest in like wildlife education and wildlife communication. So like it really does make a difference. Like just a very, very small personal connection can really leave a lasting spark. And that was just like one letter exchange, right? Like if you can imagine like how, like what kind of fire might have been lit if I had had the ability to like have a live conversation with a scientist. Oh my gosh, I can only imagine like what that would have done.
Yeah, absolutely. I mean, I didn't talk to a scientist my entire childhood at all. Never.
Probably a lot of people, especially people that live in maybe like rural areas that don't have access not only to like scientists, but also to things like museums or zoos or aquariums. Like if they're in an area where that is not an option for them, like this could be kind of their lifeline to the sciences, right? Like if there's nothing near them, they don't have the option of just like going on a field trip, right?
Right. Exactly.
Yeah, I'm very thrilled that you guys are doing that. And I did yesterday tune in to you had Dr. Kaylee Swift on. Now this was a Zoom live stream, right?
Yeah, so let's talk about that. So our program is like the bread and butter of our program is matching for like personalized connections, but we also, particularly during quarantine times, have been doing live streams 4-ish times a week. And so you can tune in. We bring in people who are really awesome science communicators and talk about the cool work that they're doing. And that's also Q&A, but there may be like 100 to 500 people in the live stream. So getting that like back and forth just between you and the scientist is a lot harder to do. But they're still available for everybody to tune into. So you can check out our website at skypeascientist.com, click the events tab. Under events, it says Skype a Scientist Live, and that's where you'll find our full schedule.
That's awesome. Yeah, I tuned in yesterday and it was really amazing. I thought that Dr. Kaylee Swift did a really fantastic job. And you were on there too, also like facilitating. And I felt like it was very streamlined. It was very easy to keep up with and easy to understand. And it did feel a lot more personal that it was like live and in the moment, you know?
Yeah.
I thought it was really great. And I'm looking forward to tuning into more now that like this is the perfect time for it because everybody's at home and everybody
like we've got nothing better to do. Right.
So I did it. So I turned on the stream yesterday while I was working on something else. And thankfully I have two screens. So I had like the stream on one screen and my work on the other screen. But like that would be the perfect thing for somebody to like turn it on for your kids, like give them a break for like give yourself a break from watching Frozen 2 for the 35th time.
Exactly.
And watch a stream from a scientist instead.
Yes, exactly.
Amazing. Before we wrap up, did you have any other like current ongoing projects that you're working on, or like how can people connect with what you're up to?
Yeah, so you can find me personally at Sarah with an H Mac Attack. So that's SARAHMACK Attack on Twitter, Instagram, and TikTok. I post a lot of invert stuff onto TikTok, and so and everywhere for that matter. So that's me. But you can find Skype a Scientist on Twitter at Skype Scientist. You can find us on Instagram at Skype a Scientist. We post pictures and little stories about each of our scientists who have participated in the program. We do like 3 a day because we have so many scientists. And the website, skypeascientist.com. You can support our mission at patreon.com/skypeascientist. And we also are doing these trivia nights for adults specifically every Thursday night. And you can find that information probably best by following me on Twitter because the tickets sell out so fast that like you kind of have to be on it. But I'll put that on our website too.
I saw that you had one with Allie Ward.
Yeah, we had one with Allie Ward from the Ologies podcast yesterday. Yeah, Allie and I are buds, so I just was like, "Yeah, you want to do something silly?" And she was down.
That's amazing. I love that so much. Well, thank you so much for spending so much time talking about, not only Bobtail Squids, but also the awesome science communication work that you've been doing. I feel so enriched and I feel so enlightened, and I'm just very appreciative of you and all the work you do.
Yeah, thanks for having me.
No problem. All right, I will talk to you later.
All right, cool. Bye.
Thanks. Bye.